Dear students, in the section 2, in your fourth chapter, you have two concepts: mean value theorem and rules theorem. Okay, so we are going to talk about these two, and they have a condition, they have the rules. So please understand, it's easy, it's just 2 points, no more. Here we have the rules theorem. You see that if f of x is continuous, do not forget at every point, do not forget about the condition of continuity. Okay, on the closed interval and differentiable at this point interior, then if f of a is another condition equal to f of b, then there is a c which f dash c is equal to 0. So our work is to find the value of c. Now I'm going to write the condition of what do you say, the condition of the rules theorem. Okay, rules theorem. Okay. First of all, function f continuous, for example, on the a and b. Second, f has got derivative, okay, on a and b. The third one, f of a should be equal to f of b. Okay, then if you all these conditions satisfy, then we can find what we can find c between a and b, such that f dash c, okay, first derivative is equal to 0. Okay, dear, so it's not easy, I know, for you, but it's very easy after the solving the first derivative, example. Now on the page 2 you have an example: f of x is equal to x squared plus 1 on minus 2 and 2. So you know the polynomial is the continuous function, right? F of x is polynomial and is continuous everywhere. So satisfy the second derivative, f of x is equal to 2x, which is also again continuous polynomial function. It's a continuous everywhere, so has got derivative on minus 2 and 2. The third, f of minus 2 should be equal to the f of 2. So put minus 2, you get 4 plus 1 is equal to 5, and f of 2 also again is equal to 4 plus 1, or 2 squared, is equal to 5. So f of minus 2 also equal to f of 2. The third one satisfied. Now it's time to your work, to find c. How? We say f of c is equal to 0. F of c is equal to what? F dash c, like 2c, right? F of dash c is equal to 0. So it means that if we have f of x is equal to c squared plus 1, or x squared plus 1, so f dash c is equal to 2c, right? C or x, no difference. So we have what? We have 2c equal to 0. Now c equal to 0, you find the c, which is between minus 2 and 2. You can see between minus 2 and 2 there's a c, which is 0, with derivative is equal to 0. So that's your work to find the value of c. And careful, not every time c is equal to 0. Okay, we have another example. So that's all about the rule function. As I told you, it's easy. Now we have mean value theorem, which have the same conditions as a f should be continuous on interval a and b. Second, we have what? F prime also should be have derivative on a and b. Okay, open of a and b. Okay, as a rules theorem that we have. Okay, the same, but here there is no third condition. So mean value theorem is stronger. There is no third condition. We don't need a and b, f of a and f of b are equal. No, just say there exists c. okay, such that we want to find C. Then it's your turn. C such that we have this rule: f of C is equal to f of B minus f of A. Do not forget about that. B minus A. Okay, so find the value of C. I know, again, you are confused because you don't know what I'm talking about. But here, the example. Okay, f of x is equal to x squared plus 2x minus 1 on the interval 1 and 0. So, first of all, f of x is poly, so it's continuous. It's continuous, right? The second, the derivative of x is equal to what? Sorry about this one. Here's the derivative. The second, the derivative is equal to what? The derivative is equal to 2x plus 2. So again, is poly and has derivative on 0 and 1. So now it's time to it's your turn to find the C. Find C. How? By say f prime of C is equal to f of B, do not forget, okay, minus f of A, B minus A, was equal to what? And I'm going just talking about the right hand. Then again, I am going to find the left side, okay? If I put 1, I get what? I get 1 squared plus 2 by 1, okay, minus 1. Minus, if I put 0, I get what? 0 squared plus 2, 0, minus 1. How about 1 and minus 0 is equal to 1? Okay, was equal to what? Was equal to 2 plus 1, right? 2 plus 1 or minus 1 will go, it's equal to 2 minus 1, am I right? 0, 0 over 1 was equal to 3 over 1 was equal to 3. Now I got what? I got f prime of C is equal to 3. How about f prime of C? What's f prime of C? You know, here's the f prime. You know. But just put the C. So I get what? I get what? I will get f prime of C is equal to 3. And f prime of C will be 2c plus 2 equal to 3. So how about finding the value of C? It's easy. 3 minus 2. 2c equal to 1. C equal to 1 over 2. Okay, dear. That's all the things that you need to do. That's easy, I think. And here's another example in your page 8. Your lecture note. Okay. We have page 8, section 4.2, example 2. Okay, dear. So this example is going to talk about also mean value theorem for f of x is equal to x squared on the interval 4. And you know this is a continuous derivative. So if f continuous, f prime or derivative also has on 2 and 0. Okay, continuous. So now it's your turn to find f prime of C is equal to f of B minus f of A, B minus A, is equal to 2c directly. You know the derivative of x squared is equal to 2x, so 2c, and 2 minus 0, 2 minus 0, f of 2 is equal to what? F of 2, 4 minus f of A is equal to 0. So we get that 2c is equal to 4 over 2 is equal to 2. Then c equal to 1. That's your work that you need to do it and find it. Okay, dear. So here's the value of c is very important for us. That's all about what about the what you can say about the mean value. Forget about this corollary and this example, it's okay. Now I'm going to page 9. So we have many important things. He say what? Find the C in the mean value theorem. We solve this one, and you have these also these solutions, and also you have another 5 examples. They are very important, so I'm going to talk about this one with you. Okay, the page 9. Okay, page 9 in your example, page 9, section 4.2. You have many example 1 to 4. So how we find the C? The fourth, they are all of them. They are satisfy the condition. Okay, the condition 1 and 2 of the mean value theorem satisfied. So they are all of them. They are continuous on these intervals, and also they have the derivative of this interval. Careful, this has no derivative everywhere. You have a 0 to the other side, but if we have another things, you should be careful. Okay, so for example 2, we say there's f of c, there's interval, there's derivative, and you can find this value of c. They are all of them, they are clear. Okay, I'm going to also number 4. We have this function is continuous here, has a derivative, so put 3 here, you get square root of 2, right? Put 3 of here, you get square root of 2. So number 4, we say what? F of x is equal to x minus 1 on the 1 and 3. So you are going to say that f of prime c is equal to f of b minus f of a, b minus a, which is equal to derivative of here is equal to what? Is equal to, am I right? 1 over 2 c minus 1. How about the derivative, the value of here? If I put 3 here, I am going to square root 2. If I put 1 here, I am going to get 0. Also 3 minus 1. Am I right? I got 0 because I put the 1 minus 1. So finally, 1 over 2 square root c minus 1 is equal to 3 over 2. And you can find, 2, no 3. Now we are doing by crossing both sides. It's clear that you will get 2 square root of 2 square root of c is equal to 2. Okay, and both can be divided by 2. We'll get this one, and c minus 1 will equal to square root. Now try to square both sides, you will get 1 over 2, and try to put the 1 to the right side, and you will get 3 over 2. That's all you need to find. Okay, dear, here's your 3 over 2, the value. Try to use these also again. Now here we have something else. Checking and using hypothesis of the mean value or rule theorem, mean value theorem or rule. You come and give the reason why you can satisfy or not. So in this function, as I told you, at the 0 we cannot find the derivative because we have a cusp, we have a corner, something like that. So that's why we say that this one does not satisfy, does not differentiable at 0 in this interval. How about here? How about here? The same example, but here we can say that, and here we can say is not available. It is not, does not exist. Why? Because the interval changed. As I told you, at the 0 and 1 it's okay, but in the something minus 1 and 1 is not okay. Why? Because the 0 here and the function is not differentiable as 0, because you know why? There is no value of 0. We solved this one in the first page here, that we will get what? We will get Let me find for you why we cannot. In the 4.1 example 4 page 5 we mentioned this function that y is not differentiable at this point. Here you have a cusp. So if I am going to talk about the function, it's okay from here to the other side or from here to the other side, but if I talk about the function from something that's 0 inside the interval, so that is not differentiable. That's why. Okay, dear. So here the same function that you have to not forget about what I am going to say is we have this function is derivative from the 0 to the other part. So okay, but if the 0 inside the interval, we cannot talk about the derivative of this function. How about the other function? This function is not has no problem. You can find the derivative and continuity that we mentioned in the chapter 3. So you can see it's okay, differentiable. How about this function? Also the number 7 is not. How about the numbers 8? Look, they are not continuous. There's a difference. It does not continuous at 0, because in this part you get 0 and that part you will get 1. So the right side is not equal to the left side, so that's why the limit does not exist and the function is not continuous, and go on. So the whole information in the chapter 3 here repeated and applied also again for about this function. That's all about the 4.2, which is about talking about the rules theorem. Okay, rules theorem and mean value theorem, and this has got 3 conditions: f continuous, f prime exists, and f of b should be equal to f of a. Okay, but here just they have the 2 conditions, f continuous and f prime exists, and that's all. And the rule for here, the result for here, the f prime of c is equal to 0, and find the value of c. But how about here, f prime of c is equal to f of b minus f of a, b minus a. That's all that we have in this section. Have a nice time. See you in the next video. We are going to talk about monotonic and phase derivative. See you there.